Welcome to the first video on turning effects of forces. In this video, we'll be going through a moment of a force. So, first thing we'll look at is the quantity known as moment. So, when two non-collinear forces, meaning they do not lie on the same straight line, the two forces don't lie on the same straight line, this causes the object to rotate. One such example is when you have a pen lying on a table. So this is, say, a pencil lying on a table, and you apply equal forces on the two ends of the pencil. This will cause the pen to rotate in, for example, this direction, anti-clockwise. Okay, and this effect of the pen rotating is known as the moment of a force. This symbol is given by this, and the SI unit is this, the Newton meter. We can understand this better when we look at the equation for moment, which is moment equals to force times perpendicular distance from the line of action of force to the pivot. Okay, so to understand what line of action of force to the pivot means better, we have this example of example 1. So draw and label clearly the perpendicular distances from the force to the pivot. So this is the force, and this point here is the pivot. So for this first example, it's rather straightforward. The distance between the pivot and the force is simply the perpendicular distance. For the second part of the first example, to find the perpendicular distance, we can't just draw a straight line because this is not perpendicular, right? So in order to do that, we have to extend the force and use the line of action of this force to find the perpendicular distance. So in this case, this distance here is the perpendicular distance from the line of action of force to the pivot. Okay, likewise for the third example, we will extend this force, and this here would be your perpendicular distance. Okay, and for the last part of the first example, the line of action, when you extend the line of action, it cuts straight through the pivot, and hence you can see that there is no perpendicular distance. And since torque or moment of a force is given by force times perpendicular distance, if my perpendicular distance is 0, my torque will also be 0, since anything multiplied by 0 will give you 0. Okay, and torque is another word for moment of a force. You can also call it the turning effect of a force. Okay, so in example 2, we need to find the turning effect of each of the following forces. So to find the turning effect, the two things we will need are force and the perpendicular distance. Since the force is already given, all we need to find is the perpendicular distance. So using torque equals to force times distance, moment equals force times distance. Force is 5 newtons, and distance is, in this case, the perpendicular distance is this, because the right angle is over here. So the perpendicular distance is 80 cm or 0.8 meters, which will give you 4 Newton meters. Okay, so when you multiply newtons with meters, you get Newton meters, and hence that is why the SI unit for moment is Newton meter. Okay, and the second example, or the second part of the second example, moment equals to force times distance times perpendicular distance, and if this is the pivot, this is the force, then this here would be the right angle, and so the perpendicular distance is 12 cm. So force of 15 newtons multiplied by 0.12 meters gives you a moment of 1.8 Newton meters. Alright, moving on. Remember that a moment is a vector quantity. Vector meaning that moments consist of both magnitude and direction. Okay, so its direction is either clockwise or anti-clockwise, and moments of in the same direction will add up, and moments in opposite directions will cancel each other out. So we'll explore more of this in example 3. So what is the resultant moment in this first example? To find the resultant moment, you simply add up all the moments acting in the same direction or subtract if they are in the opposite directions. So for this case, we have two forces, the 3 Newton force and the 7 Newton force. Both will give rise to a moment. So resultant moment is equals to 3 force times distance plus force times distance. The first force, let's take the 3 Newton force, multiplied by the perpendicular distance, which is 1.5 meters in this case, and plus 7 newtons. And recall that the distance is the perpendicular distance from the line of action of this force to the pivot. So it will be this entire distance over here, which is 1.5 plus 0.5 equals to 2. So 3 times 1.5 plus 7 times 2 equals to 4.5 plus 14 equals 18.5 Newton meters. And what is the direction of this moment? It is clockwise, because notice both forces cause this beam to rotate clockwise. Okay, so that is for the first part of example 3. For the second part, let me use green ink instead. Notice how there are two forces again, but this force, the 7 Newton force, causes this beam to rotate clockwise, whereas the 3 Newton force causes the beam to rotate anti-clockwise. So we have to subtract these two moments to find the resultant moment. So first, let's take the clockwise moment. Clockwise moments equals to force times distance equals to 7 multiplied by 0.5 from the force to the pivot, which is equals to 3.5 Newton meters. And for the anti-clockwise moment, it's equals to force times distance equals to force of 3 newtons multiplied by 1.5 meters equals 4.5 Newton meters. Okay, and finally, to find the resultant moment, we have to take one direction as positive. So let's take anti-clockwise as positive. Anti-clockwise moment, resultant moment is equals to 4.5 is positive, subtract away 3.5 to get 1.0 Newton meters. And so the resultant moment is 1.0 Newton meters anti-clockwise.